Looks like people are filtering in now, and we'll get started. I'd like to thank the break sponsors. There's a big sign, and they've got some desks out there. Go ahead and visit their tables. They're giving away T-shirts and stuff like that. Breaks have been really nice, and the breakfast is always really good, and it's always nice to come to Nanog and have a nice breakfast, especially if you're like me and your breakfast is half a bottle of gin every day. So it's really nice to have some bacon and eggs every once in a while. We're going to start off with a very interesting presentation, I think, from Ed Lewis on a nice sort of statistical quantitative look at root and TLD DNSSEC deployment observations.
Okay, thanks. Okay, so I need the pointer. Go to the first slide. Yesterday, Doug Maughan was talking about some of the things that DHS were doing for the internet, and he talked about an effort to promote DNSSEC, and he said he'd been doing this his effort had been out for 8 years or so. I've been with DNSSEC for about 16 years or so, somewhere in there, and I decided to look back at the archives of Nanog to see the last time I talked about DNSSEC in a full presentation was 2001. That was 11 years ago, and in that presentation I was talking about what this thing was going to be. So this presentation is now a decade later, and it's actually about deployment, early deployment observations. And the reason why I began doing this work was our company decided to roll out DNSSEC, and we wanted to figure out what are the parameters needed to run DNSSEC. The protocol definition is out there on paper, but there are lots of numbers you need to configure. How big are keys? How often you do things? So I started saying, well, look at the TLDs. They're all experts. We'll see what they do and kind of come up with some averages, see what happens out there. In doing this work, what became more interesting was looking at the behavior of operations in adopting a new extension to a protocol. One of my ground rules in this presentation is I don't name names. I'm studying operations of a lot of places. Operators have different requirements, so they do things differently in places. They all also sometimes have a herd mentality. But the data I have is trying to look at the policies, not the actual availability, the precise numbers of whether they're up or down. And I'm not going to try to judge the operators' decisions, just kind of report on what influences them. And actually, some of this is from feedback I've already gotten over the past year presenting on this topic. One of the things I talk about is the differences of what I see from what I expected to see. And I was asked one time, why would I have expectations? And this is because early on, I was participating in writing some of the early code, workshopping the protocol. At that time, as a developer of the extensions, we expected the protocol to roll out a certain way. We designed it for certain requirements. We saw this is where we want to go with the protocol. And we assumed that in the future it would be run a certain way, so we built things into the protocol. That's where the expectations come from. It's from basically the IETF side of the house. I've been working with operators now for almost 10 years in developing this stuff. It's fun to go back and say, what things do operators pick up out of the RFCs, and what things do they not take from the RFCs? That's become an interesting topic to look at. Adoption is not a topic that I'm really trying to put out too boldly here, but this just gives you an idea of where we are. The large green slices are those zones that don't do DNSSEC. I didn't choose the color scheme. It was kind of thrown on me. So you can see right now, most still don't do DNSSEC in the TLDs, the root zone and the TLDs. There are 11 test TLDs out there that are DNSSEC signed. I don't count them. I don't think it's fair to count them as operational examples. And it gives you an idea of where we are over about a 15-month change. What I did find interesting about the deployment, though, is it's seasonal. It's pretty obvious that engineers don't like to work during vacation time in the summer, and we skip the holidays. There are no changes in January. In putting the slides together, I have a couple of bullets at the bottom there, a couple of dots there. In August, one zone was signed. In September, one zone was signed. And then I went on vacation for 2 weeks in October, and I had to rush to make this set of slides when I came back. Since I made these slides, 3 zones have signed in the last week. It's October. It's time to make changes, I guess. It also seems to coincide with all the conferences. Okay, so in trying to measure DNSSEC, I'm not going to give you a DNSSEC tutorial. I'm not trying to get deeply into what all these parameters mean, but this gives you an idea of what I measured. First thing is key management. First thing we look at is what kind of keys are put into play, what are the roles of keys, what kind of cryptography is used, and then how often do changes happen in the keys that are under management. Then I'll talk about something involving the trust chain, the so-called DS record, and a measure of what it means and what it shows about operators. And then I get into the negative answer section, because the negative answer has a choice to make in DNSSEC, and so it's interesting to see who makes choices, which way they go, and how they configure that. And then finally, I do mention something about a non-parameter, which is message response size, because that's a sticky thing for DNS. The key roles, there are two kinds of keys that are popular in DNSSEC, as a KSK and a ZSK. I only mention that because I'm going to refer to KSK and ZSK quite a bit in here. It's not important what the two roles are for this presentation. We just expect KSKs to be physically longer than ZSKs. That's about all you really need to keep from this slide here. Oh, by the way, this role split up is completely optional for the protocol, but everyone I've measured does it. One zone wasn't doing it, and it converted in the last couple of months to do this also. So it's popular for the TLDs because it makes sense for a situation in which we all share with the root zone. Cryptography. In cryptography, when we developed the original software, we assumed that operators would sign the zone with multiple algorithms for diversity, that it would be good to sign with RSA, it would be good to sign with DSA. So we wrote the software very carefully to handle all this stuff. We wrote very intricate protocol designs to say, if you see this kind of key and this kind of key, you can mix and match your trust chain and so on. The first thing that I was surprised is that for any single operator, they picked one algorithm, just one, which in retrospect actually makes sense. It saves a lot of time to sign with just one algorithm. And there's no need to have multiple algorithms out there. There's no reason to have the diversity that we assume would be there. Over time, cryptography improves, and we see new algorithms out there. And when a new one came out there, we looked at, the next thing was, which is more popular, the new or the old one? And on the next slide, I'll give you the number. In fact, it's right here. In the old days, the old was popular, and nowadays, the new one has just overtaken it. But what's interesting is only 2 operators have switched the algorithm they use. They just stick with what they have, because the incremental benefit isn't there to force one to change algorithms and all the headaches that's involved with this. Key lengths were suggested in RFC 4641, which is one of the original operational recommendations documents. 96% of all the signed zones today in the TLD space use the exact recommendation of the ZSK, and 92% do the KSK. Not a lot of imagination there. Putting the two together, using 2K, KSK, 1K, ZSK, 90% follow exactly that. Conversely, this is a population of about 90 to 93 zones, depending on when I do the statistics. There are 2 zones that don't use either number. One of them, I'm sure, is a mistake. And that's, I'm sure of, is because they just came online and they reversed the 2 numbers. The other one, though, is a zone which consciously went with different numbers because they did a study and decided that was the optimal way to run security and message sizes. And I asked the operator about that months ago and got into stories about, well, this is what our tools were helping us do and so on. And they said they were thinking about going to the follow the herd sizes. But when I told this story at a bunch of operators, a meeting of a bunch of operators about 3 months ago, one person piped up and said that when they were designing their DNSSEC, they went and commissioned a study. What's the right size keys for this? And they found out that the key sizes used by this oddball operator were the right ones. They went up the chain with that recommendation, but the review committee says, no, don't do what's optimal according to your studies. Follow the herd. Just pick 2K, 1K, and just go along with that. So peer pressure has come to bear on operational choices. So, and I have at the bottom of the line, it says, this is one sign that better guidance on cryptography is needed. When I looked at my 11-year-old slides, I actually had a slide saying unstudied cryptography, tell us what to do. Nothing's happened in 10 years. Lifetimes and durations. How long do I use a key? The recommendations or the expectations were 1 year for KSKs, 1 month for ZSKs. After we started rolling things out, the root zone was signed 2 years ago, I think. Crypto experts said, why? You don't need to change keys until they break. But then operators said, well, if they break, we have to change them, we have to practice, and so no one really has any good idea of what to do at this point. So I looked at the frequency of changes, and even though I have more than a year of observations, KSKs I can't measure. There's just not enough of them have changed. Only 4 of them have come and gone in my observations, and I don't want to draw any more conclusions beyond that. ZSKs, there have been a lot. Operators tend to like to change the ZSK because you can do that by yourself without involving anyone else. The KSK involves the parent. Expectations here are about a 1-month use period of the ZSK. In reality, first thing you notice, the pie charts here are a bit more multicolored. The pie charts are all, the slices are more equal in size. That means people are, here operators make choices, 1 month, 2 months, 3 months. Only 20% here follow the RFC. One thing I see right away is that when it comes to picking the size of something, an operator will go to the RFC. But when it comes to how often do you do something, we'll not do what the RFC says. We'll do what we feel we can handle. Response sizes, and I say this because I'm also an operator, and we actually make that decision that it was too much work to do it every month. Response sizes, space and time. If we like to have, you have a primary working key, you have a backup key. If you put them both in the same message, the message gets bigger. What this is showing here is that roughly 2-to-1 ratio of operators that put out only one key and minimize their message size to operators that put both keys out there and don't worry about the message size right now. Some of the thoughts on this, the size of a message in DNS is a serious consideration. 512 bytes was the traditional limit for DNS. We see a lot of firewalls that have limited us to that. And in general, there's been a lot of padding around the DNS system to make sure that DNS doesn't cause problems for the rest of the internet, and we deal with the size of these things. We are concerned about large-size DNS responses for the amplification attacks, and there's also a concern about UDP fragmentation out there. But then again, I don't think anyone has any really good point data on this stuff. I've seen presentations talking about this issue, but we don't really have any definitive, we've got to be in these numbers right now. You know, it's evident the operators are tinkering with key management. It's a new field. Just like 10 years ago, we still don't have a really good handle on how to deal with cryptography within the DNS community. And I've been saying this for quite a while. We need, you know, people, if someone does studies on this, it would be very helpful to see as academic studies about what is a good size key? Does it need to be 1K? Does it need to be 2K? There are some guidance documents out there, but still no real practical experience. On the other hand, too, there have been some operators that have gone against the grain completely. There are 6 TLDs that didn't do any changes to their keys out there. In fact, one operator has actually never made a change to any of his DNSSEC parameters since he started. And I talked to him about it, and he's aware he's done this way. A second example is one operator has actually recycled keys. They use a key. It comes in, they use it, they throw it away, but then it comes back again. And I talked to that operator too, and this is actually what they're doing. These are things we didn't expect to see in the protocol development days, but on the other hand, no one's had a problem. So we don't know if these are good or bad ways of doing things, good or bad sense of security, but some are trying different approaches. We have some documents that we can refer to. But we don't have best practices anywhere. No one's documented the best way to do things. We argue about the best way to do things all the time, but no one's got a consensus. And I think the reason why I bring this up is in answering RFPs for DNS service, some of the RFPs we want compliance with RFC 4641. And I'm trying to say is that that's not a document you want compliance with. It doesn't always make sense. The document wasn't meant to be a compliance document. And in fact, it's even self-inconsistent in the way it specifies some of the numbers in there. And also, it has a key clause that if for the next 5 years, these are the way you should do key management. And that was written 6 years ago, so it's timed out by itself. So if you're going to write an RFP for our DNS service, read the documents you want to see compliance with and actually describe what you want out of them, because not all of them have requirements. Now, in building the trust chain, this is another element of DNSSEC. It has to do with the DS record. And there are 2 things to look at the DS record. How long does a DS record take to appear? And then also, how is it put in the zone? And in the first, this delay, best analogy I have for this is kind of like when you sign your zone, it's kind of like getting engaged. Putting the DS record into the root zone is like now getting the I do's. I'm married now. It's the commitment part. So this shows that, once a zone has signed, how long are they sure that this signing is going to work before they want to count when they make that commitment? What's kind of surprising in there to me is the first green slice is so big. That's immediate, meaning that there are zones out there that have signed themselves and in the same day had a DS record put into the root zone. The asterisk there is those are zones that did not exist the day before. There were 2 zones that went from nothing to DNSSEC in one day. They weren't even in the root zone. Again, I don't name names, so I don't give you the examples. The next yellow is 2 weeks, and then orange is 3 weeks. But usually by 3 weeks is when I've seen most TLDs have decided to go ahead and finish the DS part of it. There have been some that take a little bit longer. The gray slice is someone that took so long that I thought they were never going to do it. And then one day they surprised me. In RFC 4509, which defined a new hash algorithm for the DS record, there's an interesting operational suggestion, I guess you could say. It said that when this document was put out there, we had one hash algorithm, and all the software out there does that today. But we're publishing a new one out there, and not all the software understands this new hash algorithm right now. They understand the hash algorithm, but doesn't understand the DS record's reference to it. So you have to maintain the old configuration and the new. So for the time being, put out the old hash and the new hash. So in this chart here, the green slice shows that the zones that only have the old hash out there. They've not adopted this RFC support yet. The yellow show the zones that do both. They do what the RFC says. They put out the old and the new. And the orange show the zones that only have the new and disregard the old value. Now, any 2 of these slices are compatible. The green and the yellow, or the yellow and the orange, that is, are compatible. The problem is that right now, because we have some zones which only have the old hash, and we have some zones with the new hash only, all the clients have to understand both. So they've pushed the pressure onto the clients to maintain compatibility for the old and new. And the reason why we have the new one is some people feel the old one is susceptible to being hacked, basically. So interesting thing here is that the RFC says that we should keep the old around as long as we need it. But we don't know what that's going to be. There's no way to tell in the DNS what the client's capabilities are. We can't measure how many of the clients don't do the new or don't do the old. The reason why there's so many that say they only have the new out there is because the root zone signed only with the new hash, I believe. And that's been the justification for some of the operators. But we do need, in the DNS protocol, to have a way to measure capabilities of our clients. The third thing I measured here was the no factor. How do you say no? Most TLDs use NSEC3 over NSEC. I'm not sure that decision necessarily is a generalizable decision for all zones out there because NSEC3 has certain advantages for the TLDs. But that's the way it is. It is about 3/4 of the TLDs do actually use NSEC3. So NSEC3 has some operational recommendations. One is that you use a salt. A salt is something you use in there. And it says you should change the salt every re-signing. And it also has an iteration parameter, which should be a low number. Now, the problem with that document right now is that every signing is kind of like a batch operation. Like, when do you sign your zone? Well, TLDs don't sign our zones. We sign records as we need to, or sign sets of data as we need to. It's all incremental. So looking at the salt change frequency is actually kind of interesting. The green slice are those that have never changed their salt in all the time I've been looking. That's kind of excessively not doing work in a way, although no one's sure that it's a bad idea because no one's ever cracked this. The yellow slice is the other end. Those are zones that change their salt at least daily. In fact, one is every 10 minutes. I found that by looking at their data, every 10 minutes they actually do change their salt. And that has implications for having to re-signing a lot of stuff in the zone. It's a lot of work to change the salt. And then there are a few that, in the other color slices, that have varying levels of how often they do make changes. And they do it all on clock. Of course, we don't have a batch signing day, so it's like every month, 2 months, or 3 months when you see new salt out there. kind of a fun thing to measure is what is the salt value. The salt's supposed to be a bunch of hex digits. Random is better than not. I pick a bad fella is in many zones. Operators tend to use the same salt across the zones they run. Zones to operators are not one-to-one, by the way. Bad fella, coffee, beef, scalable, and baseball. And the bad fella, when I asked the guy who did bad fella, they said, well, we thought no one would notice. Or they forgot to change it when they went to production. Baseball is in use by, and again, name no names, by a registry that has nothing to do with baseball. And I said, that's our game. Sorry, you can't use it. It's still there. In fact, that nation hasn't produced a Major League Baseball player in about 100 years. So, yeah, I hold that against them. NSEC 3 iterations. This is just interesting because it's supposed to be low. It doesn't matter. They're recalculating some number over and over again. 0 means that the TLD, and I know this not from observations but from talking to people, that they didn't use NSEC 3 for the hashing. They used it to get access to the opt-out for the scalability of what NSEC 3 gives them. The yellow starts those who do 1, 2 to 5, and you get through half of them already. 6 to 10 is the next big slice. The interesting thing in the document is that it says don't go above 150, and somebody does 150. So apparently someone scanned the document and said, oh, I see a number, 150, let me use it. That's a guess. I've never been able to talk to that TLD. Again, the word low is relative. Is one's low, is 6 low? Who knows? So we have these different interpretations out there. So I went pretty quickly through the first couple of slides, so I'm actually running ahead of time, but my summary slide here, and I wanted to say was one of the points I should make, and I didn't have a place for it earlier, is in talking to the operators, one of the major factors is that the tools that they can use. A lot of times the choices are forced on them by the open source software choices they made earlier in their process. And so implementers of tools are very important to reach out to and say, look, if you put these parameters in here, it will get used. It's easier than letting the operators actually fine-tune down to the last nub. Key changing algorithms, which I mentioned only 2 have done, it's possible, but for quite a while we thought that there might have been a problem with the protocol spec because none of the tools could do it. We figured out it was the tools that couldn't do it. It wasn't that the specification was wrong. The guidance on cryptography is needed. I wrote that down without realizing how ironically predictive that was 10 years ago. And really, I pitched this at certain areas which are more research than operational. And maybe someone out there is starting to go out and say, what if iterations goes from 1 to 10 and so on. The DNS protocol improvement we need is to start measuring when we can get rid of old cruft in the protocol. It's just accreting stuff right now. We can't get rid of anything. It's not just DNSSEC. We have all these RR types that we've allocated that no one uses. There's like 100 RR types out there. We use maybe 10 to 20 of them are actually active use. And finally, we all like to avoid vacations and holidays when we do our upgrades, and that shows pretty clearly. So, leave it for questions.
We have time for 1 or 2 questions, if anyone has a question. That was actually very complete, Ed. You answered the question I was going to ask. So
sorry. Should have warned me.
In your summary slide. So, any questions for Ed? Seeing none. Okay, thanks, Ed. That was very good.
All right, thanks.